is the very much, some people think like what actually the very difficult part of chemistry, not in level, even A level, right? The chemical calculation is very easiest chapter when you study with questions and types of question. If you have seen this module that I can give that to your people, I have given a different types of question which is related to the question came in last year's examination, right? Okay, before I start this lesson, right, you must know some equation. This chapter, this chemical calculation class is all about what equations related to what, related to unit, the grade, unit number, grade 10, unit 10, unit grade 10, unit 7, right? And also unit 7, and also sometimes the grade 11, unit number 3 sometimes, right? So maybe it will be tough for you all, but if you see this calculation, before you start this calculation, you must know one thing. The very important thing is the grade 10, chapter number 20, chapter number 7. It's a really tough, I can say what, um, tough unit maybe when you compare other chemical or chemistry units. Before I want to start this one, you must know that some of the terms in this class, right? I can go straightly for questions types, but this is very important. You can easily understand. You must know the masses. You know the different types of atoms, the atoms or the elements, you know, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, something like that. Those atoms, one mass, one atom, come to the point. Those one atom's mass is very much low, very much less. Very much, very much less, which means you can't even measure that mass of that atoms. So for example, if you look at this mass of carbon atom, the mass of carbon atom is 1.993 into 10 to the power, I can zoom it here, minus 23 gram. It's very much less. It's a very, very much less amount. You can measure it. Even mass of sodium, it's also what, 3.8, 3.819 into 10 to the power 23. It's also very much less. You can measure it. It's really tough. Mass of chlorine, if you look at this one, chlorine atoms, the atomic unit, mass of the atomic number of chlorine is 335.5. You may have studied that. No, 17, that mass number. 17, you may have studied that. But this mass of chlorine is 5.9. Look at this, minus 10 to the power minus 23. 10 to the power minus 23. It's very much less or very much lighter mass of the lighter mass of these atoms. Look at this potassium. The potassium mass is 6.476 into 10 to the power minus 23 gram. It's a very much lower, fewer, lighter mass of atoms. It's really tough to understand. It's really tough to use this mass in calculation. It's really tough to use this mass in calculation, actually in calculation. So scientists, they have introduced what actually the new term. What's that actually? It's seriously, you must know this one. This is not the question. This is not the class for theory, but for your help and for your understanding. I have I have I'm just explaining something that you want to know when you go for before you want to start this question. So please understand the terms. The terms is very important. The first I have given, what's that? The first term is what actually? The mass of one atom. Look at this, one atom. One atom means something like that. Look at, if you look at this, for example, if you look at this chalk, right? It's a chalk. For example, if it's a 5 gram, then you take one part of chalk. Excuse me. Okay, if you take this 5 gram of chalk, you take 1 point of one particle of this mass. It's called what? Chalk particle. I can say this is what? Chalk particle. So like that, if you take carbon, if you take one particle, one atom of carbon mass is this is the one, 1.99. Very small amount, very small mass, and very small mass. Look at this, 10 to the power minus 23, here minus 23, minus 23, minus 23. Look at this one. These masses are very much less or very much lower. So that's why scientists, those they thought what actually they can't use this mass for calculation because of the easiness of students and the coming generation. They introduced what? Relative atomic mass. They have introduced relative atomic mass. Look at this relative atomic mass, the definition. How many times of an atom of a given element weighs? As much as 12. They are not never going to ask this definition for your examination. Seriously, don't remember. If you don't remember, if you remember this equation, if you have written this equation for your examination, if they ask, they will give the maps. So commonly when you give equation, they will give maps. So what is relative atomic mass is equal. Relative, why they have introduced relative? Because the mass of atoms are very much, what's that actually, very much less. For example, carbon, sodium, potassium, chlorine, something like that. So they have introduced relative atomic mass. Relative atomic mass can be called as what actually, see, look at this, can be called as, look, AR here. What is that? The mass of one atom of element over 1 over 12 into mass of 12C carbon atom. Look at this one. 12C carbon, why they have introduced this 12C carbon? Because you know carbon had two isotopes. What is isotope? Same mass number, different mass number, same atomic number, isotopes. I already said when you come to this class, you should refer these notes which is in your book or your note or whatever notes you must study or refer, revise and come. Otherwise, it's tough to remember, get the idea. Because I will talk too much. You know, that's how we should teach. So 12C carbon, why? Because there are two isotopes carbon. One is 12C6 and second one 1214C6. There are two isotopes for carbon, but they are introducing here what type of carbon? 12C carbon. This is an isotope. So you should remember this one. If you look at this one, for example, if they ask, for example, something like that question, what is the correct formula of relative atomic mass? If they give something like that, 14C6, and that is wrong. So you should see this 12C carbon atom. That is very important for this one. So the relative atomic mass is the mass of one atom. For example, look at this. I'm just going to show one. I'm going to explain one here, right? This class will end 8:15, sometime 8:30, or I'll finish 8:15, right? So please stay. Look at this one. For example, I'm going to show this one here. Mass of carbon atom. How much? 1.993 into 10 to the power minus 23. I'm going to find the relative atomic mass or the relative atomic mass of carbon, right? So just see. So how I want to write here mass of one atom. I should write mass of n atoms. One means n. Sometimes you will forget n. So you should one atom of which element? Carbon element. So you should put here carbon element over 1/12 into, I'm writing fastly because I have to move faster. 1/12 into mass of carbon atom. You don't need this one. This class is not about the theory. Please understand. I will go for question, but for your help, for your easiness, right? For your easiness, I'm explaining this. The mass of one carbon element is, if you look at this one, you bring it here, and 1.993 into 10 to the power minus 23, 3 gram, right? Gram. Over, what I can write mass of one carbon atom also 1.993. You must have referred this one. You should have been studied this one. Minus 23 gram into 1/12. Look now, I can cut both these. Then if this 12, if it go upwards, then the relative atomic mass would be, what's that? 12. So this is what's happening here. Actually, the mass of one carbon atom is 1.993 into 10 to the minus 23 gram. But they are not using for calculation. Scientists introduced what? Relative atomic mass. And that time, here, the mass of relative molecular mass, if you put here, then what will happen? The 12 will be the answer. Again, I'm coming. If I put here the mass of one atom instead of atom, if I put sodium here, look at this. What is the mass of one mass of sodium? One atom of sodium, one mass of here. See, look at this one. 3.89 into 10 to the power minus 23. 3.819 into 10 to the power minus 23. So if I apply that 3.819 into 10 to the power minus 23 into this equation, I will send this video, no problem. Don't ask me always. Okay. So if I use this mass of one atom instead of this atom sodium, 3.819 into 10 to the power minus 23 gram. Look at this. Over 1 over 12 into mass of one carbon atom. What is the mass? You know that 1.993 into 10 to the power minus 23 gram. Look, I am going to cut this gram and gram. I can cut this one. And if I divide and multiply this one, the answer would be approximately 23. That is why the relative atomic mass of sodium, we write sodium is equal 23. Something like that, if you apply for this equation for oxygen, if you use oxygen, for example, or I can use, if I use potassium, what is the mass of potassium? One atom mass, 6.476. 6.476, the mass of potassium. Look at this one. If I apply that here, mass of one atom, instead of this one, you apply potassium here, 6.476, the mass of one potassium atom, 6.476 into 10 to the power minus 23 gram into 1 over 12 into the mass of one atom is 1.993 into 10 to the power minus 23 gram. Then I can cut this gram and gram. And if I completely simplify and also finish that one, the answer would be potassium relative atomic mass would be what? 39. This is how this 39 is coming. So can someone say, if I use for oxygen, what would be the answer? 16. You know this. The relative atomic mass of oxygen is 16. If I use this for hydrogen, what would the answer? 1. If I use for aluminium, what would be the answer? 27. If I use chlorine, what would be the answer? 35.5. If I use sulfur, what would be the answer? 32. If I use for potassium, what would the answer? 31. That is what we call that what relative atomic mass, because it's the real numbers and those numbers can be used for calculation. you can't use for calculation these kind of very less amount of the mass of atoms. That's why the scientists introduced relative atomic mass. Something like that, if you come to this one, if you come to this one, the atomic mass unit now. It's just a theory, not the theory class. Please understand, right? I'm just being fast. I don't explain this much. I will explain so many things, but I'm just explain to get an idea about what is mass, atomic mass, what is relative atomic mass, what is atomic mass unit. The atomic mass unit is simply the mass of 1 over 12 C carbon isotopes over 12. Can I write like this one here? This one. 1 over 12 into mass of 12 C carbon 6 isotope. Both are equal. Both are equal. The atomic mass unit. See, 1 over 12 into mass of 1 over mass of 12 C carbon. Look at this one. If I apply this, the mass of 1 over 12, you don't need to remember these all. This is bloody things for exam. Just remember this one. That's enough. Mass of 1 over 12, 12C carbon isotopes is what actually? 1.993 into 10 to the power minus 23 gram. We know that. Gram, look at this one, gram. Over 12. Over 12. Then the answer would be for this one is 1.66 into 10 to the power minus 24. This is called atomic mass unit. Atomic mass unit, look at this one here, gram, here no unit. So it won't have what? It will have unit, what's that? Gram. Now look at this one. So come to this point, actually, the relative atomic mass unit, I can write this. Wait. Relative atomic mass unit is equal. Instead of this one, look at this one. Instead of this one, I can write mass of an atom of, excuse me all, this will link expire by 10 minutes and I will send another link, you can connect, right? Mass of atom of, what is that? Atom of the element, here this one, element, over, instead of this one, I can use what? Atomic mass unit. Instead of this one, atomic mass unit. So look at this one. What is the relative atomic? You must know this one. They are not going to ask this calculation for examination. Seriously, they are not going to ask. But they will ask this equation, which means in MCQ. In MCQ, you may have seen so many questions. So the thing is, you must know the correct way of writing this relative atomic mass. There are two equations for relative atomic mass. One is mass of one atom of element over 1 over 12 into mass of 12C carbon atom, or else this one and over atomic mass unit. The value of atomic mass unit is 1.66 into 10 to the power minus 24 gram. Everything is in your book. If you don't have, if you don't have a proper notes, right? Please you use and refer your someone notes that you can easily understand. So then, if you come to this one now, look at this one. We talked about this mass of atoms. We talked about atomic mass unit. This is one, and we talked about relative atomic mass. And there is another equation for relative atomic mass: mass of one atom of element over atomic mass unit. Look at this one. We have done all the sums, all the things, and we have found potassium 39, sodium 23, and they have given a specifically relative atomic mass. Hydrogen, what's that? 1. Helium 4. Lithium 7. You don't need to remember for your O-level examination these things. You don't need to remember these. They will give, actually, definitely they will give. But in your term examination, they will not, sometimes they will not give. So don't think about this, your term examination. I am talking about only O-level examination. They will give this relative atomic mass. But how it is coming? These relative atomic mass are coming or are calculated how? Using this method. Using this method, relative atomic mass are calculated. That's how they have found that every atoms or elements of 20 elements relative atomic mass. Simply you don't need to remember these all. But if you are an O-level student, I must say one thing, you must know this order. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. You must know these 20 elements order-wise. Order you must know this one. Otherwise you can't. Really tough. You must know this order: hydrogen, helium, lithium. If I ask 11, you must say sodium. If I ask 17, chlorine. If I ask 20, calcium. If I ask boron, 5. Something like that you must answer. It's really tough if you don't remember. If you don't remember, please remember these all the elements in order. Right. Let's move to relative molecular mass now. Relative molecular mass also same as like what? The relative atomic mass. Instead of this one, see, instead mass of molecule, in here mass of atom, here if it's an atom, atomic mass, if it's an atomic mass, then mass of a atom of element, you may have seen that. But here, relative atomic mass. So the mass of a molecule, they have given this one, molecule of an element or a compound over same as what we use this one. 1 over 12 into mass of 12C carbon atom. What is that I can give instead of this one? This one. Atomic mass unit. You can easily say AMU, right? So these are the small theories of this one. Even if you don't know these theories, you can do the questions. This link will expire by 3 minutes, then we will go to the next link, right? Okay. Next, come to this one. Look at this one, for example, if you look at this one, if you use this equation, we will be talking about the relative molecular masses. For example, carbon dioxide. You must know these carbon dioxide relative molecular mass is 44. You must know this one. I'm not going to explain this one, how to find this one. I have a question like that, but this is not the class for this to study. It's about questions. If we use that, ammonia, NH3, the relative atomic mass of ammonia is 14 and the hydrogen is 1 and 1 into 3, altogether the relative molecular mass of ammonia is 7. If you use this equation, you will get 17. But don't think about too much of this equation. Please remember everything what you have to know. You must remember at least this equation. You must remember, that's all. Remember this equation. Remember this equation. And also, you should have a small idea about this one, right? So I'm going to stop this link and we'll go to next link. It's a dark also. So let's move to group and you can find this.